Hello, viewers. In this video, we'll be discussing one-to-one function and their inverses. So we start by looking at the definition of one-to-one function. We say a function with domain A is called one-to-one if no two elements of A have the same image. It means if you take x1 and x2 to be from the domain of F, then f of x1 is not equals to f of x2 whenever x1 is not equals to x2. Another way of saying that is that if you have f of x1 to be equals to f of x2, then x1 must be equals to x2. If you have a function satisfying this condition, then we say that function is one-to-one. Now, let's see example here. If you look at these functions, here we have f and g. Now, if you look at function g, you will see that what? G of 3, what is g of 3? G of 3 is 4, and also g of 2 is 4. So it means that g of 3 is equals to what? G of 2. But we can see that 3 is not the same thing as 2. So it means this function is not one-to-one. Because if g of 3 is equals to g of 2, and you have this 3 not to be equals to 2, so it means that the function is not what? Is not one-to-one by definition. Because by definition, whenever the images are the same, then your inputs, if you have the y values to be the same, then your x values must be the same. But here, you can see that g of 3 is equals to g of 2. But the inputs, which are the x values, what are the x values? 3 is x1, 2 is x2, but they are not the same. So this function is not one-to-one. But if you look at in this case, we don't have that condition because f of 4 is equals to what? Is equals to 10. So f of 3, it's equals to what? 7. And f of 2, it's equals to what? 4. And f of 1, it's also equals to what? Is equals to 2. So here, this type of function is what? Is one-to-one. Because you see, whenever the images are not the same, then the x1 and x2 are not the same. So you don't have two x values that have what? With different y values. So this is just the simple definition of one-to-one. Now, how do you check whether a function is one-to-one? We can use the definition. Either we use this definition, we can use this one or this one. Both are the same. They are equivalent. Or we can use what we call the horizontal line test. So a function is one-to-one if and only if no horizontal line intersects its graph more than once. So unlike in the case for function, if you want to test whether a graph is a function, you do a vertical line test, right? If it's cut more than once, then you say it's not a function. But horizontal line test is used to test whether a function is one-to-one. So let's go into solving problems. So for example 1, you say decide which of the following function is one-to-one. So we're just going to do it using two ways. The first one is just what I call by definition. You can call it analytical as well. So what does this mean? This means you will assume that the y values are the same. Two y values are the same. So f of x1 is equals to what? F of x2. But where is this x1, x2 coming from? x1 and x2 will have to come from the domain of f. And here you can see the domain of f is what? Is the whole real number, real line. Now, what does this mean? F of x1, just substitute x1 here. So this will give us what? Will give us x1 to power 3 is equals to x2 to power 3. And then what is the goal? The goal is to check, can we get x1 equals to x2 always? Yes, here we can take the cube root of both sides. We take the cube root of both sides, we will have so the cube root of x1 cube is just x1, and the cube root of x2 cube is just what is x2. So it means that our function is 1-to-1. Why? Because we assume that f of x1 equals to f of x2, and we end up having x1 to be equals to x2. This is true for any x1 and x2 in the domain. It means for any real numbers, because the domain of this function is the whole R. So therefore, f is what? Is 1-to-1. Now, the next one is by using the horizontal line test, which I call HLT. So here, what do you do in this case? You can call it horizontal line test, or you call it graphical method. Here you have to what? We have to sketch first. And if you know what is our function is f of x is x cubed, which has a 0, right? Which I can write as x minus 0 to power 3. So this function has a 0. The 0 of this function is 0, right? This 0, and you have an odd multiplicity. So it means if you graph this function, it's going to look like something like this. But when you get to 0, it's going to be tangent to the x-axis before it crosses, because the multiplicity here is odd. So, and now if you look at this, you can have, we can have a horizontal line test. Just draw a horizontal line. And you will see that irrespective of how many horizontal lines you draw here, the black line, the lines will only intersect the curve only once. So it means we can also conclude that the function is what? Is 1-to-1. So here also we can say that f is what? 1-to-1. So let's move to another example. Now, for example 2, we have f of x is equals to x squared. So same thing. Here, what do we do? The same. We will have definition, and we have the HLT, which is the horizontal line test. By definition, we will assume that f of x1 is equals to f of x2. And we will take x1 and x2 to be in the domain of f. The domain of f, xx, is still the whole R, right? Now, what is f of x1? This will give us x1 squared is equals to x2 squared. All right, so what can happen here? Here we have to take the roots. So this is going to be even roots. x1 squared, it's equals to what? x2 squared, right? Now, you can see that since x can be negative, x1 can be negative, it can be what? Positive, because it's coming from where? It's coming from the domain of f. And the domain of f is the whole R. So because of that, we will need an absolute value here. So x1, as well, x2 also, you will need to have an absolute value. So what does this mean? This simply means that to remove the absolute value, it means x1 is equals to x2, or we can have x1 is equals to what? Minus x2. But you can see here is okay because x1 is x2, but here is not okay. So this is not okay, but this is fine. But since we already have this or, it means any of this could happen. So it means if you assume x1 is equals to x, if we assume that the images are the same, it means the y values are equal, But that does not necessarily mean that the x values will be equal because we have this situation here. So our conclusion will be f is not what? Is not one-to-one. Okay, then the next one is to what? Is to use the horizontal line test. This is x squared. X squared is easy to see that this is just what you can write this if you just this is 0x minus 0 all square, and we know that this is simply this. The multiplicity is 2 of 0 is 2, so it's just going to be tangent, right? And if we look at we try to do the horizontal line now. So if you have a horizontal line, clearly it's going to intersect more than one point. So since it's intersecting more than one point, we know it's not going to be one-to-one. For example, only one is even enough for us to see. And you see that we have the horizontal line intersecting the curve twice. So f of x equals to x squared is not what? One-to-one. All right, so let's go to C. Now for C, here we have a restriction. So clearly we will see how to do this in both the using definition and also graphically. So by definition, you're still going to what? We're still going to assume. So we assume that f of x1 is equals to f of x2. Still yet, x1 and x2 will still come from the domain of f. Now, what is f of x1? But now, what is this domain? So here we have to be careful here. The domain of f here is restricted, so x is less than equals to 0. So we can say that x1 must be less than equals to 0, and x2 must also be less than equals to 0. We can say this. Okay. Now, f of x1 is what? Is x1 squared equals to what? X2 squared. Right? Now we can take the root of both sides. So you have root of x1 squared is equals to the root of x2 squared. Now, surely this will be absolute value of x1 is equals to absolute value of x2. But x1 is less than 0, so less than equals to 0. Here is also less than equals to 0. So it means that here could be, if both x1 and x2 are zeros, you will have 0 equals to 0. So we can assume that these are both negative since we are dealing with less than. So we take the negative part. And since they are negative parts, it means this is just going to be minus x1 is equals to what? Minus x2. So x1 is going to be what? X2. Please take note what I did here. We are simply using the condition. This means x is what? Negative or 0. This also means x1 is negative of 0 because of this restriction. So because of that, we already have an absolute value. So if x1 is 0, if x1 is 0, absolute value of 0 is just going to be 0, right? So if x1 is equals to 0 and x2 is equals to 0, we're just going to have 0 equals to 0, which means they are equal, right? But the other case is when it is less than, when it is negative. If x1 is negative, it means here is negative. x2 is negative, also it means here is negative. So to remove the absolute value from here, it's going to be minus x1. So to remove the absolute value from x2 is going to be minus x2. So minus will go with minus, and then we have x1 equals to x2. So we can conclude that f is what? Is 1-to-1. Now, Using the horizontal line test, we need to graph. So what are we trying to graph? We're trying to graph this function x squared, where x is less than or equals to 0. And what that means is that what? We have to graph, that's the same graph we have above, but in this case, we have to delete which part? We're interested in the part that is less than or equals to 0, so we have to delete this right-hand part. So we have to go with this one only, because this is x less than or equals to 0. And clearly, you will see that this satisfies the horizontal line test, because every horizontal line you draw will only cut only once. So here we can say f is what? Is 1 to 1. F is 1 to 1. So we can conclude that this f is what? Is 1 to 1. It's 1 to 1. All right, now we go to the D, example D. So D is just a what? It's just a line, and we want to show that this line is 1 to 1 as well. So how do we do it? The same story. We just need to assume that's x1. So we're using definition. And also t. So we assume again that f of x1 is equals to f of x2. And here we have to let x1 and x2 to come from the domain of f. The domain is the whole R. So we will have 3x1 plus 4 is equals to 3x2 plus 4. Clearly, 4 can go. So we have 3x1 is equals to 3x2. And we can easily conclude that x1 is equals to x2. So this is good. So it means that f is what? Is 1 to 1. So graphically, we need to just draw a line. What line is this? This is a line of slope. What is the y-intercept? You can see that the y-intercept is at where? Is somewhere at 4. So we just know this is going to be a line, right? Because what is the function? Remember, our y is equals to what? 3x plus 4. So if x is equals to 0, what do we have? So our y-intercept is going to be at where? At 4. So it's going to be positive, right? And you can see that this is a positive slope. So you just have like a line. This is the line. And you can see what will be our x-intercept. Our x-intercept is just what? You put y to be 0, right? And you will have what? Put y equals to be 0, you will have minus 4 over 3. So this is minus 4 over 3. And clearly, this is just horizontal line test. All our horizontal line will cross only at where? At one point. So we can also conclude that f is 1 to 1. Right. For E, we have an absolute value function. So for this absolute value function, we can also use definition, even though there is restriction, it's still fine. So here, what is the definition? You let f of x1 to be equals to f of x2. But here, since there is a restriction, so it means your x1 also has to be less than equals to 1, and your x2 also has to be less than equals to 1. So what is f of x1? F of x1 will be absolute value of x1 plus 2 equals to absolute value of x2 plus what? Plus 2. Now, we know how to deal with absolute values, right? So what can we say? If x1 is less than what? Is less than 1. If x1 is less than 1, what is this point here? So take any number less than 1. For example, if you take, you can take 0. Yes, it's less than 1. It means that here would always be what? Could it always be positive, or could it be negative at some point? So here we have to be very careful, because if you take x1 to be less than, for example, if you take x1 to be maybe 0. If you take x1 to be 0, you see this will be what? Will be positive. This will be what? Let's take x2 also to be 0. So you have both positive. So you can easily remove the what? The absolute value. But if you take x1 to be a negative number now, let's say you take x1 to be minus 5. If you put minus 5 here, this is going to be minus 5 plus 2 is going to be minus 3. So it's a negative number. So it means that this condition here does not make does not make the quantity inside your absolute value to be positive. Sometimes it could be positive, sometimes it could be negative. So what we're going to do in that case is just use what we know. This means x1 plus x2, it could be equals to what? X2, so this is plus here, x2 plus 2, or x1 plus 2 is equals to minus what? X2 plus 2. Okay. Now, the reason why we're doing this is because I told you that this condition is not enough. If you take x to be 0, you see this will be plus. But if you take x to be minus 5, it will be negative. So since you are not getting just one value or one sign, then you just have to do this one. So if you try to solve this, this will be fine. This 2 will cancel 2. So x1 is equals to what? x2. This looks good. But if you come to this other side, you will see that x1 plus x2 is going to be minus x2 minus 2. So here you see x1 is positive, x2 is negative. So they cannot never be equal. And here this is 2, this is minus 2. So you can say x1 is not equals to x2. So since we have this is good and this is not good, you can conclude and say that what f is not what is not 1-to-1. Now, graphically, you need to graph this one using the horizontal line test. This is x plus 2. And what is this? This is just the absolute value. X plus 2 will be somewhere here. Here will be minus 2, right? Then you will have this. This will keep going. But now this side, because there is a condition. What is the condition? X less than equals to 1. So it means you have to stop at 1. And then here it has to be close because of the equality. So this is the graph. And as you can see from the graph, if you try to draw the horizontal line, clearly the horizontal line, it crosses more than what? More than 1. So you see f is not what? It's not 1-to-1. All right, so let's go for f. By definition, and the same thing, we will also like to use the horizontal line test. Now, this function, you assume that f of x1 is equals to f of x2. Here, f of x1, x2 is coming from the domain of f. So what is this? This will be 49 minus x1 square is equals to what? Root of 49 minus x2 squared, right? Now, if you look at this, when we say x1 and x2 belongs to the domain of f, what does that mean? It means if they are in the domain of f, it means that what is inside here cannot be less than 0. It means it cannot be negative, right? Because if 49 minus x squared is negative, then you'll be taking the root of a negative number, which is going to be imaginary. So here, x1, x2 is on the domain of f. It means that even if you square both sides, 49 minus x1 squared equals to what? 49 minus what? x2 squared, right? So if you square both sides, what will be the answer? The square can cancel the root, and you don't need an absolute value. Why? Because 49 minus x1 squared we know is definitely positive. It cannot be negative because we picked x1 and x2 to be from the domain, right? So it means here will just be 49 minus x1 squared equals to what? 49 minus x2 squared. And so what does it mean is that what? 49 will go with 49, and you have x1 squared is equals to x2 squared. There is a minus here. But now we see that what? The minus will go. So we have x1 squared is equals to x2 squared, right? Okay. Now, getting to this point, we need to take the what? The root of both sides, which is the square root of x1 squared is equals to the square root of x2 squared. Now, here, we don't know what is x1, x2, whether they are all positive or negative. So we need an absolute value. Here, we know that x1 and x2 belongs to the domain of f. But let's even do it roughly. What is the domain of f? If you want to find the domain of f, let me just find it here. Domain of f is what? Since this is, what is f? F of x is what? Root 49 minus x squared, yes? So the domain will be 49 minus x squared should be greater or equals to what? 0. And this means that 49 is greater or equals to what? X squared. So which means that x squared is less than or equals to what? 49. Then you can take square root of both sides and square root of what? 49. So this will be absolute value of x is less than or equals to what? 7, right? Yes. Now, what is the meaning of this? This means minus 7 is less than or equals to x is less than or equals to 7. So when we are talking about this domain, it's actually nothing but from where? Minus 7 to what? 7. So here, when we say x1 and x2 belongs to domain of f, what we're actually saying, in other words, is that x1 and x2 belongs to where? Minus 7 and what? 7. So you can see that if x1, if you take x1 from minus 7 up, minus 7 close to minus 7 in this interval, the square, 49 minus that square will always be positive. Also, 49 minus x2 square will always be positive, or it will be 0 at worst. So that is why you see that when we squared here, we don't need absolute value. But when we get to this point, you see, we're only dealing with x1 and x2, but x1 and x2, based on this domain, it means sometimes they could be positive, they could be what? Negative. So it means you cannot neglect the absolute value in this case. So we have to use absolute value of x1, and this is equals to absolute value of x2. And clearly here, it means x1 could be equals to what? x2, or x1 could be what? Minus s2. So what it simply means is that here, this is good, but you can see this one is not good because x1 is not equals to x2. So your conclusion is that f is not what? 1 to 1. All right. Now let's go back here and try to do the horizontal line. Now for the horizontal line or the graphical method, we have to what? We have to graph. We have to graph. So how do we graph? To graph this, we can see that this function is what? Is root of 49 minus x squared. This is just like a half circle. But if you want to see this clearly, remember I just discussed that the domain is going to be what? Minus 7 to 7, right? So you can pick some values of x, and also you can pick and get your function, right? So we pick some value of x from this domain. For example, you can pick minus 7. If you pick minus 7, what will be the y value? Put minus 7 here, you have 49 minus 49. This is 0. You can take minus 5. If you take minus 5, it's also in this interval. you will have root 49 minus 25, which is going to be around root 24. You can add, maybe you can take 0. If you take 0, this is just going to be 7. We can take also 5, which is still going to be, put 5 because of the square, it's still going to be the root of 24. And then we can take 7. If you take 7, you will go back to 0. So at least this should give us a rough sketch. What this means is that we are starting from minus 7, and we are going to 7. That is the domain, right? Now, how do we do this? So if x is minus 5, at minus 7, we know we are at 0. At minus 5, we're going to be somewhere up here, which we can just call it root of 24. Root of 24 is 4 point something. And also, if you go to 5, it will still be the same value, as you can see. But at x is equals to 0, we have the y-intercept, which is somewhere at 7. So roughly, and at 7, you see we have 0, which is here. So we're going to have just like a circle, something like this. So this point, let's readjust it. The point has to be on the curve. So this is the rough sketch of the function f of x is equals to 49 minus x squared. Now look at this one. This domain is not given to us from the question, so but you have to find it so that you know which values of x you can plug. And just like we did, how do you find the domain? Just let inside here to be greater than 0 and solve it. So here you will see that if you draw these lines, the horizontal line, it cuts more than 1. So f is not what? Is not 1-to-1. All right. So let's take the final one, which is G. Now for G, also we can have the two method as well. Definition. And what's HLT? For definition, we assume f of x1 is equals to what? F of x2, x1, x2 belong to the domain of f. But what is the domain of f in this case? You can see it's just the whole R, except what's? Except minus 2. So it is R minus 2. So f of x1 is going to be 1 over x1 plus 2. F of x2 is going to be x2 plus what? Plus 2. So if you flip, you can flip or you cross multiply, you're going to just have x1 plus 2 is equals to x2 plus 2. And easily you can see that x1 is equals to what? X2. This is the only case, so it is nice. So we can say f is what? Is 1-to-1. Graphically, we can start with the function of what? We can start with the function of 1 over x. So, and so it means that if you start with the graph of what? You can start with this one, let's say g of x, to be the reciprocal graph. And you will see that f of x is nothing but what? G of what? X plus 2. So we can use transformation. It means that if you have the graph of G, to get the graph of f, you just need to shift 2 units to the left. So, but what is the graph of G? So the graph of G is just this one, which is the normal reciprocal graph, 1 over x, which has a vertical asymptote at 0, right? But now you need to shift 2 units to the left. So if you are shifting 2 units to the left, it means our vertical asymptote will shift somewhere here. So by transformation, it will just become, okay, so this will be -2, right? And then you will have this one here, and also this one here. So this is your g of x, and this is our f of x. So we just shifted it 1 unit, 2 units to the left. So clearly you can see that this will also fail. Will it fail? No. It's going to what? Satisfy the horizontal line test, because if you go this way, you go this way. This is only crossing how many points? Only 1 point. So we can conclude that f is what? Is 1 to 1. Okay. So what have we done so far? We've used both the definition and the horizontal line test to check whether a function is 1 to 1 or not. All right, so I hope this is clear. If you have any question, you can put it in the comment section. Thank you for watching.